A planet changed its spin overnight. Saturn, the jewel of our solar system, began rotating backwards without warning, defying every law of physics we hold sacred. By the end of this exploration, you will understand the incredible theories scientists are now considering to explain the impossible. What unseen force could flip a world so suddenly, and why did its beautiful rings remain perfectly calm amidst the chaos? What would you do if the sky itself started breaking its own rules? It all began with a routine check of the Cassini spacecraft's archived data. Scientists were tracking the familiar, lazy dance of Saturn's cloud bands, a task as normal as checking the weather. But the numbers on the screen made no sense. The high-altitude winds, which for centuries had raced eastward at over 1,000 miles per hour, were now blowing just as fiercely in the opposite direction. At first, the team at the Mission Control Center assumed it was a glitch, a phantom in the machine. They ran diagnostics, checked the software, and recalibrated their instruments. The impossible data remained. A quiet alarm spread through the global community as other observatories were quietly called upon for verification. The Keck telescope in Hawaii, the Hubble Space Telescope, even the newly launched James Webb, all turned their gaze towards the ringed giant. Each one returned the same terrifyingly clear result. Saturn was spinning backwards. This was not a slow shift or a gradual wobble. By comparing data from just days prior, they confirmed the reversal happened in a single, silent Earth night. The initial reaction was pure, unadulterated disbelief, a refusal to accept what the laws of physics declared could not be. One astronomer described the moment as feeling the ground fall away from beneath science itself. In hushed, secure communications, top experts shared their findings, their messages a mix of professional caution and profound awe. They knew the world was not yet ready to hear that a fundamental truth of the cosmos had just been broken. The very stability of our solar system rests upon a set of rules we believed were unbreakable. To grasp the sheer impossibility of what happened at Saturn, you first have to understand the cosmic clockwork that governs every planet's spin. This begins with a simple concept: angular momentum. Think of a figure skater pulling their arms in during a spin. They rotate faster because they have concentrated their mass closer to their center. Now scale that up to a planetary level. A planet forms from a vast, swirling cloud of gas and dust, a protoplanetary disk. As this material collapses inward under gravity, any tiny bit of initial spin becomes massively amplified, just like that skater pulling in their arms. This is the conservation of angular momentum in action, and it gifts every newborn world a powerful, stable rotation that is meant to last for its entire life. This is why Earth completes its familiar 24-hour cycle with such unwavering reliability. It is why the giant Jupiter, a planet so vast it could swallow every other world in our system, spins with dizzying speed, making a full rotation in just under 10 hours. Once this spin is set, it becomes an intrinsic part of the planet's identity, a fundamental property that resists change. The forces that can alter this spin over cosmic timescales are immense, yet incredibly slow. The gentle, persistent tug of a moon's gravity can create tidal friction, gradually applying a cosmic brake. A catastrophic impact from an asteroid the size of a small moon could, in theory, deliver enough of a blow to affect a planet's rotation. But these are processes that unfold over millions of years, leaving a faint fingerprint across eons. What we witnessed at Saturn defies this entire framework. This was not a gradual slowing down or a gentle nudge. It was a full 180-degree flip in a single night. The conservation of angular momentum, one of the most sacred laws in all of physics, was not just bent, it was seemingly thrown out entirely. An impact large enough to cause an instantaneous reversal would have had to be so colossal it would have vaporized the planet, scattering its remains across the solar system. Tidal forces lack the raw, violent power for such a sudden act. This event leaves no room for the slow, graceful dance of celestial mechanics. It points to something else entirely, a force or an interaction so far beyond our current understanding that it forces us to question the very bedrock of astrophysics. If the rules we have always trusted can be broken so effortlessly, what other secrets is the universe keeping? For decades, Saturn was a model of consistency in its relentless spin. A full day on the ringed giant clocks in at just 10 hours and 33 minutes, a dizzying speed for a planet so vast. This furious rotation flattens Saturn at its poles and bulges its equator, giving it the distinct shape of a squashed ball. But how do you time the spin of a gas giant, a world with no solid surface to track? Scientists relied on two clever clocks embedded within the planet itself. The first was its powerful magnetic field, which pulses with a steady rhythm of radio waves. For years, this radio heartbeat was considered the planet's true metronome, a reliable signal of the interior's rotation. The second clock was written in the clouds. We mapped colossal jet streams like the 1,000-mile-per-hour wind racing eastward at its equator. We stared in awe at the perfect six-sided hurricane churning at its north pole, a geometric storm so stable it acted as a permanent landmark. Missions like Voyager and Cassini spent years charting these atmospheric features, creating detailed maps that showed a system in powerful, yet predictable motion. This was the established rhythm of Saturn, a symphony of wind and weather conducted by a spin that never, ever varied. The baseline was not just well understood, it was etched into every textbook. That profound certainty is what makes the reversal so deeply unsettling. When you know exactly how a clock is supposed to tick, its sudden, inexplicable backwards count is not just a surprise, it is a profound violation of reality itself. The alarm came not from a person but from a machine. An automated alert from the Hubble Space Telescope pinged across the globe, flagging an irregular motion in its continuous monitoring of the solar system. The data was unequivocal. Spectroscopic measurements, which usually read the light from Saturn's atmosphere like a cosmic speedometer, were now showing a profound and impossible shift. The telltale sign of gases moving toward us, a blue shift, was now appearing where a red shift from receding material should have been. The entire atmospheric shell of the planet was screaming that it was now spinning the wrong way. Within hours, this was corroborated by a global network of ground-based observatories. Teams in Chile and Hawaii pointed their most powerful telescopes at the giant, capturing high-resolution video that removed all doubt. They watched in stunned silence as familiar cloud formations, giant swirling storms that had been tracked for decades, were now drifting counter to their lifelong paths. The timeline was the most terrifying part. By comparing time-stamped data from multiple sources, they pinpointed the reversal to a window of less than 6 hours. In the span of a single earthly evening, a planet 10 times the size of Earth had simply changed its mind. The immediate scramble was to understand the how. Supercomputers at research institutions across the world were tasked with the most urgent simulation in history. They were fed every known variable, every law of fluid dynamics and gravity. One by one, the simulations failed. They either showed the planet tearing itself apart in a cataclysm of fire or remaining stubbornly, correctly spinning forward. No conventional model could produce a silent, instantaneous flip. This computational dead end pointed to a force operating outside known physics. But the greatest paradox was not just the reversal itself, it was what remained perfectly, eerily still. Saturn's magnificent rings, a delicate tapestry of ice and rock, showed no sign of the chaos that must have gripped the planet's interior. Think of it like this. If you were to suddenly grab a spinning globe and force it to stop and spin the other way, everything not nailed down would be hurled into chaos. Yet Saturn's rings, which are not nailed down at all but merely orbit in a delicate balance with the planet's gravity, were completely undisturbed. This meant the core of the planet reversed its spin without transmitting that catastrophic force to the rings just above it. It was as if the engine of a car had instantly reversed while the car itself continued moving smoothly forward. This single observation shattered every initial hypothesis and forced a global, clandestine collaboration. Astrophysicists, planetary scientists, and experts in gravitational theory began sharing data on secure channels, their usual competitive barriers dissolved by a shared, humbling realization. They were not just looking at a broken planet, they were looking at a key to a door they did not even know existed. The first and most desperate hope was that our eyes were lying to us. Could this entire cataclysm be a ghost in the machine, a collective hallucination born of faulty data? The global scientific community mobilized not to prove the anomaly but to destroy it. Teams at NASA and the European Space Agency began a forensic-level investigation into their own instruments. They recalibrated the Hubble's guidance systems against known, steady pulsars. They checked for solar flares or cosmic rays that could have scrambled the data, finding nothing. They then compared readings across the entire electromagnetic spectrum. The infrared eyes of the James Webb Space Telescope, which see the planet's heat signature, showed the same reversed atmospheric flow. Radio telescopes listening to the planet's inner magnetic pulse confirmed the same impossible rhythm. Every wavelength of light told the same story. The most powerful test was a blind analysis using decades of archived Saturn data. Researchers fed old information into their processing software, secretly inserting simulated reversal events. The systems detected every single one, proving the algorithms were sound. When they processed the new, real data with the same tools, the reversal flag screamed back at them. They even enlisted independent researchers, giving them the raw numbers with all identifying dates and sources stripped away. These outside experts, with no preconceived notions, arrived at the same terrifying conclusion without any prompting. As a final check, any orbiting probe with a backup instrument, any telescope with an alternate mode of observation, was tasked with a single objective: stare at Saturn. From every vantage point, with every kind of technology, the result was unanimous. After weeks of the most intense scrutiny imaginable, a quiet, humbling consensus emerged. There were no more bugs to find, no more errors to blame. The impossible was simply true. Saturn had reversed its spin. This was the moment the mystery truly began, for it meant the answer could not be found in our old textbooks. We were now forced to venture into the unknown, to consider explanations that sounded more like science fiction than astrophysics. What theoretical door had just been blown open by this silent, cosmic event? The first clear signs of the cataclysm were written in the clouds. Saturn's atmosphere, once a masterpiece of orderly chaos, descended into pandemonium. Its iconic jet streams, those relentless rivers of wind that had carved the planet into distinct bands, were the first to rebel. The 1,000-mile-per-hour easterly gale at the equator simply choked and died, replaced by a turbulent, churning slowness. In its place, new, monstrous storms began to boil up from the deep. These were not the familiar, contained vortices, but continent-sized tempests that erupted across the latitudes, their swirling faces colliding and merging in a violent atmospheric war. The planet's beautiful, banded appearance began to smear, its sharp borders dissolving into a hazy, featureless soup of amber and gold. Temperature sensors told a story of profound shock. Regions that had been frigid for eons suddenly experienced rapid heating, while other areas plunged into a deep freeze, all because the planet-wide engine of atmospheric circulation had been thrown into reverse. The heat that once flowed in a predictable pattern was now trapped or redirected, creating hotspots and cold spots where none had existed before. Then came the most symbolic loss. The North Polar Hexagon, that stunning, six-sided hurricane that had stared back at our probes for decades like a permanent cosmic landmark, began to falter. Subsequent images showed its sharp geometric edges softening, its furious rotation stuttering. Within weeks, the hexagon was gone, vanished into the general polar turbulence. Its disappearance felt like the erasure of a fundamental truth. Yet, amidst the destruction, new phenomena flickered to life. Brilliant, unpredictable auroras ignited near the poles, far more intense and chaotic than the usual light shows. These weren't the gentle curtains of light we recognize. They were frantic, lashing tongues of energy, suggesting a magnetic field in profound distress, its internal dynamo struggling to recalibrate after the core's sudden reversal. This atmospheric chaos became a crucial window. For the scientists watching, the turmoil was not just destruction, it was a diagnostic tool. By tracking how storms formed and energy propagated across the globe, they could infer details about the planet's deep interior, about the density of its layers and the forces that had gripped the core. The atmosphere remained in this state of violent flux for months, a constant, real-time laboratory of a broken world. Every new storm, every temperature spike was a piece of the puzzle, a clue whispering from the depths about the nature of the force that could flip a world overnight. But if the atmosphere was in turmoil, what was happening to the one part of Saturn that had impossibly stayed perfectly calm? While the planet's atmosphere tore itself apart, its magnificent rings hung in the void with an almost insulting calm. This serene stability was the deepest part of the mystery. Every law of motion told scientists they should be witnessing an apocalypse. The rings are a fragile sea of ice and rock, from dust specks to mountain-sized boulders, all held in a delicate balance between Saturn's gravity and their own orbital momentum. If the planet's core truly reversed its spin, the sudden change in its gravitational influence should have sent a monstrous shock wave through this delicate structure. The rings should have rippled, then shattered like a tranquil pond struck by a boulder. Yet the initial data showed nothing. Observations from the Cassini probe's archived radar maps, along with every major telescope, revealed no new gaps, no sudden clumping, no great collisions. The rings spun on, pristine and unbothered, as if the world they circled had not just broken a fundamental law of the universe. This presented a paradox that threatened to undo every conventional theory. How could the engine reverse without the car even shuddering? The answer lies in the strange way gravity works over distance. The rings are not physically attached to the planet. They are free-falling objects held in orbit by the pull of Saturn's core mass. Their speed and stability are governed by that central gravitational force, not directly by the planet's rotation. Think of it like this. If you were orbiting Earth in the International Space Station, and Earth suddenly started spinning backwards, you would not immediately feel a jolt or change your orbit. You would just see the continents below you moving in a new, impossible direction. In a similar way, Saturn's rings are so far from the planetary surface that the immediate, violent reversal of the atmospheric shell and the deep interior's spin did not instantly translate into a destructive gravitational command. Their orbital dance was set by the planet's total mass, which remained unchanged, so they simply continued their eternal waltz. But as researchers stared for weeks and then months, their powerful instruments began to pick up the whispers. They were not the violent upheavals they expected, but subtle, profound shifts. The Cassini radar, sensitive enough to map the density of individual ring particles, began to detect a slow, strange migration. Wave patterns, usually stirred by the gentle nudges of shepherd moons like Prometheus and Pandora, started to change their rhythm. These density waves, which travel through the rings like sound waves through air, began to propagate at slightly different angles and speeds. It was as if the entire ring system was very slowly recalibrating itself to a new, silent vibration emanating from the planet below. The particle densities in certain regions began to shift, not clumping into new moons, but tightening and loosening in a slow, cosmic breath. This pointed to a delayed transfer of angular momentum. The planet's sudden flip had not sent a shock wave, but it had created a new gravitational landscape, a subtle change in the fabric of spacetime around Saturn. The rings, over time, were beginning to feel this new reality and adjust to it. The shepherd moons, those tiny gravitational shepherds that help maintain the sharp edges of the rings, were now working overtime, their own orbits subtly perturbed as they struggled to contain the slow-motion ripple effect. Researchers are now monitoring these subtle shifts with the intensity of doctors watching a patient's vital signs. They are running simulations to see if this could lead to a larger wobble in the ring plane over the coming years, or trigger new, unexpected collisions deep within the ring structure. The ring's incredible insulation from the initial chaos has become a priceless laboratory. By watching how this delayed reaction unfolds, scientists hope to measure the exact way angular momentum is being transferred from the planet's reversed core to its celestial jewelry, a process that might finally reveal the true nature of the force that reached out and spun a world backwards. With every conventional explanation falling apart, the world's leading physicists were called into the mystery. The first task was to eliminate the obvious cosmic catastrophes. Could a rogue planet, a dark wanderer from the void, have slammed into Saturn? The answer was a resounding no. An impact of that magnitude would have left the entire solar system ringing like a bell with gravitational waves, a signal our most sensitive observatories would have detected instantly. There would also be a glowing cloud of vaporized debris, a brilliant scar in the infrared that simply did not exist. What about a microscopic black hole? Theoretically, one passing through the planet could transfer enough momentum to alter its spin, but it would not stop there. It would continue on a path of destruction, leaving a trail of perturbed orbits and devoured moons, a path we do not see anywhere in the Saturnian system. Each of these dramatic scenarios was crossed off the list one by one, leaving only silence in their wake. This failure forced a profound shift. Scientists had to stop looking for something that hit Saturn and start considering that something might have happened within Saturn itself. Could internal processes alone achieve the impossible? Some models suggested a sudden planetary-scale magnetic reconnection event. Think of the planet's magnetic field as a vast web of rubber bands storing immense energy. If those bands were to snap and reconnect in a new configuration all at once, the release could, in theory, deliver a torque powerful enough to jerk the core in a new direction. Others pointed to a radical shift in the dynamics of its deep, metallic hydrogen core. What if different layers of the interior, already spinning at slightly different speeds, suddenly synchronized or slipped past one another, like a colossal planetary clutch being engaged? The energy required for such an event is almost beyond comprehension, but if some unknown threshold of internal pressure and heat was crossed, it might just be possible. Yet even these exotic internal explanations strain against the conservation of angular momentum. To truly break that law, even for a moment, requires looking beyond the physics of our everyday dimension. This is where the most mind-bending ideas emerge from the realm of theoretical physics. Concepts from quantum gravity suggest that at the very smallest scales, the fabric of reality is not smooth but foamy, with particles and energy popping in and out of existence. Under certain conditions, this quantum foam could theoretically allow for a temporary, localized violation of conservation laws. It would be a cosmic loophole, a fleeting moment where the universe looked the other way. An even more profound idea involves cosmic strings. These are not strings in the everyday sense, but hypothetical, incredibly dense flaws in the fabric of space-time, relics from the very birth of the universe. If one of these ultra-thin, unimaginably massive filaments were to sweep through our solar system and interact with Saturn, it would not hit the planet like an object. Instead, it would warp the local space-time around it, effectively redefining what forward and backward even mean for that region. The planet would not have fought against a force. It would have simply found itself in a new reality, its rotation reversed relative to the rest of the cosmos. This has sparked an unprecedented collaboration. Astronomers are feeding every detail of the reversal and the ring dynamics to theoretical physicists working with string theory and models of multidimensional space. Could dark matter, which we know permeates everything, have played a role through some unknown interaction we have not yet discovered? These are not just ideas scribbled on blackboards anymore. They are being translated into complex new models, the first scientific attempts to build a key for a door we never knew was locked. The silence from Saturn is no longer just a mystery. It is a question, one that is pushing human understanding toward a frontier we have only just begun to imagine. The silence from Saturn points toward an invisible culprit. Could the answer lie not in something we can see, but in something that permeates the very space around us? This line of inquiry leads directly to dark matter, the mysterious substance that makes up most of the universe's mass but has, until now, refused to interact with our world in any way we can easily detect. The hypothesis is as elegant as it is radical. Imagine a dense, invisible knot of dark matter, a wandering clump the size of a moon passing directly through the heart of Saturn. Because dark matter interacts only through gravity, it would not smash into the planet like a rock. Instead, it would slide through the gas and metallic hydrogen as if they were not even there. But its gravity would be felt. If this clump moved on a trajectory that was not perfectly aligned with the planet's center, its asymmetric gravitational pull could, in theory, act like a cosmic lever. It would tug harder on one side of the planet's interior than the other, applying a tremendous and instantaneous torque. Think of it like spinning a basketball on your finger and then brushing the side of it with an invisible hand, causing it to reverse its spin. The dense core of Saturn could have been given a sudden, violent twist, while the rings, orbiting far outside the zone of greatest gravitational influence, remained relatively untouched. The challenge, of course, is proving it. We cannot see dark matter directly. Our detectors on Earth are built to catch the rare, fleeting interaction with a single particle, not to map the gravitational shadow of an entire invisible mountain. So researchers have turned to a cosmic magnifying glass, gravitational lensing. They are now scouring archival data of stars that lie directly behind the Saturnian system from our perspective. The idea is that if a massive clump of dark matter is still lurking nearby, its gravity would bend the light from these distant stars in a specific telltale way. They are looking for tiny, unexplained warps in starlight, subtle signatures of an unseen mass hiding in plain sight. A related idea involves a primordial black hole. These are not the giant black holes of galactic centers, but hypothetical, tiny ones that could have formed in the universe's first moments. A primordial black hole, with the mass of a planet but compressed into a space smaller than a baseball, could have performed a similar gravitational trick during a close flyby. It would not need to collide. Its immense gravity would warp the local spacetime around Saturn so severely that the planet's rotation could be fundamentally altered, as if it were spun on a different axis by the fabric of reality itself. Supercomputers around the world are now running simulations, feeding them complex equations of general relativity to model these exact scenarios. They are testing whether such an event could produce the clean, instantaneous reversal we observed without leaving any other visible trace. If either of these theories proves correct, the implications are staggering. It would mean that dark matter is not just a diffuse halo around galaxies. It can clump, it can move, and it can directly, violently shape the evolution of planetary systems. The silent flip of a gas giant would become the first direct evidence of dark matter's dynamic power, a single event capable of rewriting our understanding of both the cosmos and our place within it. The planet's own magnetic field may have been the architect of its impossible reversal. Every gas giant generates a powerful magnetic shield, a force field born from the churning of its deep interior. For Saturn, this field is uniquely tidy, its magnetic poles almost perfectly aligned with its axis of rotation. This magnetic field is not a static object. It is a living, breathing entity woven into the very fabric of the planet. It is generated by the dynamo effect within a vast ocean of metallic hydrogen, a form of matter so compressed it behaves like a liquid metal. This electrically conductive fluid is constantly in motion, and its movement, coupled with the planet's rapid spin, generates the immense magnetic field that envelops Saturn. The key to the reversal lies in a process known as magnetohydrodynamics, where magnetic fields and conductive fluids become inseparably linked. What if this internal dynamo experienced a sudden, catastrophic instability? On Earth, our magnetic field flips polarity every few 100,000 years, a slow, gradual process where north and south magnetic poles swap places. But what if on Saturn, with its entirely different internal structure, such a flip could happen not over millennia, but in an instant? A sudden reversal of the entire planetary magnetic field would unleash an unimaginable torrent of energy. Because the field is so deeply coupled to the electrically conductive metallic hydrogen, this violent reconfiguration would transfer a colossal amount of angular momentum directly to the liquid interior. It would be like grabbing the axle of a spinning wheel and forcing it the other way. The entire deep core of the planet could have been jerked into a new spin direction by the sheer force of its own magnetic rebellion. This internal torque would then have propagated outward, taking only hours to reach the upper atmosphere and forcing the cloud bands we observe to reverse their flow. The evidence for this is already hidden within the Cassini mission's archived data. Years of observations showed subtle, unexplained variations in Saturn's magnetic field strength leading up to the event. And now, post-reversal measurements reveal a profound anomaly. The field's orientation, once so neatly aligned, now shows a slight but persistent wobble, a telltale sign of a recent, violent reconfiguration deep within the metallic heart of the giant. This theory transforms the event from an external attack to an internal planetary seizure. It suggests that gas giants may possess a hidden volatility, a capacity for magnetic chaos we never anticipated. If Saturn can flip itself inside out in a single night, could Jupiter be next? Could similar magnetic instabilities be churning within the hot, young gas giants we see orbiting distant stars? The silent spin of Saturn has suddenly given us a new lens through which to view all giant planets. It hints that the serene faces they show us may hide turbulent hearts capable of revolutions that rewrite their very identity in the blink of a cosmic eye. Deep within Saturn, beneath the churning clouds, lies an engine of unimaginable pressure. The planet is not a uniform ball of gas, but a layered world with secrets of its own. At its heart sits a rocky core, possibly many times the mass of Earth, crushed by the weight of the world above it. This core is encased in a vast ocean of metallic hydrogen, a form of matter so exotic that hydrogen behaves like a liquid metal. Surrounding that is a layer of ordinary liquid hydrogen and helium, and finally, the gaseous atmosphere we see. For billions of years, these layers have spun together, but not necessarily in perfect harmony. The different densities and fluid states mean they could be rotating at slightly different speeds, a phenomenon known as differential rotation. Think of it like a cocktail shaker, where you have dense syrup at the bottom and lighter liquid on top. When you spin the shaker, the layers move together, but they can also slip and slide against one another. Now, imagine that on a planetary scale. The stress between these spinning layers could have been building for eons, storing immense energy like a coiled spring. What if a sudden, internal trigger released it all at once? One compelling model suggests a sudden phase change deep within the metallic hydrogen layer. Under extreme and shifting pressures, this conductive fluid might have abruptly changed its state, collapsing inward by a tiny fraction. Even a minute shift in the position of such a massive layer would violently redistribute the planet's angular momentum. It would be like a figure skater pulling their arms in during a spin, but if the skater's entire torso suddenly collapsed inward, the conservation of angular momentum would demand a response, and the outer, gaseous layers could have been whipped around in the opposite direction to compensate. This would manifest as the sudden reversal we witnessed in the cloud tops, while the deep interior, the rocky core, and the densest part of the metallic hydrogen ocean might have retained much of its original spin. This was not a planet being hit, but a planet having a seizure from within, a rapid sloshing event that flipped its outer shell. How could we ever hope to see such a thing? We cannot look inside a gas giant, but we can listen to it. If we had seismic data, we could track waves propagating through the planet's interior, much like geologists use earthquakes to map Earth's core. While Saturn does not have tectonic plates, it does have internal tremors and oscillations. The Cassini spacecraft, during its final daring orbits, actually attempted to measure Saturn's subtle gravitational field in exquisite detail. By tracking tiny wobbles in the probe's trajectory, scientists can infer the distribution of mass deep inside the planet. Now, in the wake of this event, researchers are poring over that archived gravitational data, looking for any anomalies that might hint at a recent, massive redistribution of the planet's inner mass. They are also monitoring the planet for long-period oscillations, watching how the entire world rings like a bell after being struck by this internal cataclysm. The challenge is profound, like trying to diagnose the engine of a car by only listening to the sound it makes from a mile away. Yet this single, impossible event has handed us a unique opportunity. For the first time, we are not just studying the placid surface of a gas giant. We are witnessing its deep, turbulent heart in a state of profound change, a real-time laboratory that could finally unlock the mysteries of how these colossal worlds are born, live, and sometimes turn themselves inside out. Of course, the most straightforward explanation would be a cosmic crash. Could a rogue object, an asteroid or comet of unimaginable size, have simply slammed into Saturn and knocked it backwards? The physics on the surface seems plausible. A high-speed collision could, in theory, transfer enough momentum to reverse a planet's spin, like striking a spinning top with just the right flick of your finger. But the reality of such an event is far more violent than the theory. To flip a planet the size of Saturn, the impacting object would need to be colossal, perhaps the size of Earth itself, moving at a significant fraction of light speed. The energy released would be apocalyptic, far exceeding the binding energy that holds Saturn together. Instead of a neat reversal, the entire planet would be vaporized, its beautiful rings flash heated into a temporary second sun. We would have seen the brilliant flash from Earth with our naked eyes, and the infrared glow from the expanding debris cloud would still be lighting up our telescopes. No such evidence exists. There is no scar, no glowing wound, no ring of destruction. So, could a different kind of impact have done the job? Simulations reveal a tantalizing, if ludicrously improbable, scenario. For an impact to cause a reversal without obliterating the planet, the object would need to be incredibly dense and strike at a phenomenally precise, shallow angle, almost grazing the atmosphere. It would have to kiss the outer cloud tops, transferring its momentum as a gravitational tug rather than a kinetic blow, using the planet's own atmosphere as a lever to twist the interior. Think of it like skipping a stone across a pond, but if the stone were made of solid lead and the pond was 1,000 miles deep, the stone imparts its energy, creating ripples, but doesn't explode the entire body of water. Even this model strains credibility, but it leads to an even more exotic possibility. What if the impactor wasn't a normal comet or asteroid, but something far stranger and darker? A fragment of a neutron star, for instance, a piece of stellar corpse no larger than a mountain, but containing the mass of an entire planet. Such a degenerate object would be almost invisible, a dark bullet of ultra-dense matter. It would punch straight through Saturn's gaseous exterior, delivering a tremendous gravitational punch to the core before exiting the other side, leaving only a microscopic, self-healing wound in the gas. The collision would be clean, leaving no visible debris, but it would ring the cosmos like a bell. This is where the search turns to one of our most sensitive new instruments, gravitational wave observatories like LIGO and Virgo. A neutron star fragment striking Saturn would have generated a unique, sharp burst of gravitational waves, a ripple in spacetime itself. Researchers are now frantically scouring the data from these detectors, looking for a signal that coincides exactly with the moment of Saturn's reversal. Finding that signal would be a monumental discovery, not just solving the mystery of Saturn, but confirming the existence of these exotic wanderers in our cosmic neighborhood. As a final forensic check, scientists are also analyzing the chemical composition of Saturn's upper atmosphere with the James Webb Space Telescope. Even a dark impactor would have been vaporized by the immense friction and pressure, seeding the clouds with exotic heavy elements not native to a gas giant. They are searching for the scattered atoms of a ghost, the chemical fingerprint of an object that came, struck, and vanished without a trace. This impact hypothesis, in all its forms, forces us to confront a profound question about the tranquility of our solar system. We often think of it as a settled, clockwork place, but what if it is still a shooting gallery where silent, dark bullets fly on unpredictable paths? The flip of a planet may be an extremely rare event, but if it can happen once, it can happen again. The search for the impactor, whether it be a gravitational ghost or a chemical clue, is more than a hunt for a culprit. It is a census of the invisible dangers that might still lurk in the dark. When the laws of physics as we know them fail, we must look to the laws we do not yet fully understand. This search leads us into the strange realms of quantum mechanics and general relativity, where the fabric of reality itself becomes flexible. One of the most profound ideas now being considered is that Saturn did not reverse its spin within normal space, but that the space around Saturn was itself twisted. Imagine a powerful, temporary wormhole forming near the planet's core. This tunnel through space-time would not be a gateway for aliens, but a violent knot in gravity's fabric. As it formed and collapsed, its immense gravitational field could have dragged the local frame of space along with it, a phenomenon known as frame dragging, but amplified to an unimaginable degree. In this scenario, Saturn's rotation did not fight against a force. It was simply carried along by a river of space that had suddenly changed its flow. The planet's core and atmosphere reversed because the very stage upon which they were spinning was momentarily rotated backwards. This would leave the rings orbiting further out in less distorted space, largely undisturbed precisely as observed. The energy for such an event could theoretically be borrowed from the quantum vacuum itself, a fleeting loophole in the cosmos that allowed for a temporary redefinition of motion. This borrows principles from theoretical warp drives like the Alcubierre concept, where space-time is compressed ahead of a craft and expanded behind it to achieve motion. Here, the model is adapted, suggesting a bubble of distorted space-time briefly enveloped Saturn, altering its rotational dynamics without the need for a colossal expenditure of energy that would shatter the planet. The reversal was not a violation of conservation laws, but a temporary suspension, a cosmic sleight of hand where the energy was paid back to the quantum vacuum the instant the bubble popped. Another wild possibility involves vacuum energy fluctuations. At the tiniest scales, empty space is not empty. It is a seething foam of virtual particles popping in and out of existence. Normally, these fluctuations cancel each other out, but what if on a planetary scale they did not? A Casimir-like effect where the sheer scale of Saturn's presence created a boundary that suppressed certain quantum fluctuations, could have allowed the energy of the vacuum to briefly dominate over gravity. This surge of repulsive energy from nothingness could have provided the precise, instantaneous torque needed to flip the world. The challenge, of course, is that we have no technology to directly measure such ephemeral events. We are left with the aftermath, searching for subtle relativistic echoes. This single event is now a driving force for innovation in theoretical physics. Researchers are proposing new, targeted experiments to hunt for the ghostly fingerprints of these ideas. They are modeling the specific gravitational anomalies, the subtle warping of starlight, and the unique patterns of time dilation that such a space-time bubble would have left behind. They are scanning data from deep space atomic clocks, looking for any tiny hiccups in the flow of time that coincided with the reversal, a telltale sign of a localized relativistic event. The silent spin of Saturn has become a unique laboratory, not for planetary science, but for the fundamental laws of the universe. It is forcing a collaboration between cosmologists and quantum theorists, pushing them to adapt starry-eyed concepts for a real-world catastrophe. In doing so, this cosmic mystery may finally provide the crucial data needed to bridge the greatest divide in science, the gap between the quantum world and the cosmic scale, potentially gifting us the first glimpses of a unified theory of everything. Perhaps the sky has tried to tell us this story before. Long before our telescopes and probes, ancient astronomers watched the wanderers with a careful eye, recording their paths with meticulous detail. The Babylonians, master astronomers of the ancient world, tracked Saturn as a star of justice and order, its steady motion a testament to cosmic balance. Yet their clay tablets also speak of rare, terrifying anomalies, moments when a planet would stand still or turn back in its path. We have always interpreted these as simple retrograde motion, an illusion caused by Earth overtaking a slower planet in its orbit. But what if a handful of those ancient reports, dismissed for centuries as scribble errors or superstitious fears, were actually eyewitness accounts of something far more profound? Could a Babylonian priest watching the heavens from a ziggurat have seen Saturn's familiar glow flicker and change its course in a way that defied all explanation, an event so jarring it was etched into history as a dire omen from the gods? Look to the Maya, whose sophisticated calendars were built upon the precise cycles of Venus. Their codices describe cosmic battles where celestial deities could alter their nature and path. While Saturn held a different role in their cosmology, the underlying idea is the same. The heavens were not always stable. A sudden, inexplicable shift in a planet's behavior would not have been seen as a scientific curiosity, but as a rupture in the very fabric of reality, a message of divine displeasure or a harbinger of a world-altering event. These are not just myths, they are potential data points, fragmented records of celestial trauma passed down through generations. The challenge is to separate true observational memory from symbolic storytelling to find the scientific signal in the ancient noise. This search for a recurring pattern extends beyond written records and into the very Earth itself. If Saturn's reversal was a real, physical event, it must have had consequences. A sudden shift in the gravitational dynamics of our solar system would send ripples through the entire planetary family, potentially nudging Earth's orbit by a tiny, almost imperceptible amount. Such a nudge could alter our planet's exposure to solar radiation, leaving a faint but permanent scar in our climate history. Scientists are now turning to ultra-deep ice cores from Antarctica and ancient tree ring chronologies, searching for a specific, sharp climate anomaly that has no link to volcanic activity or solar cycles. They are looking for a year of inexplicable cooling or warming, a single, bad-growing season recorded in the rings of a 1,000-year-old bristlecone pine that aligns perfectly with one of those ancient astronomical reports. Finding that link would be a revolution, transforming a singular, impossible event into a rare but natural cycle of our solar system. The true power of this investigation lies in its fusion of disciplines. Archaeologists and astrophysicists are now sitting at the same table, comparing timelines of human civilization with timelines of cosmic events. They are asking if the collapse of a Bronze Age empire, often blamed on war or famine, could have been preceded by a celestial sign so terrifying it shattered the societal order. They are re-examining the accounts of Greek philosophers and medieval monks, looking for any description of Saturn that seems off, where its color, brightness, or position was recorded as suddenly and inexplicably wrong. This is not about proving ancient prophecies right, but about acknowledging that our ancestors were keen observers of a sky that may have been more dynamic and dangerous than we ever believed. Their stories, woven from fear and wonder, might be the longest-running experiment in human history, a millennia-long record waiting for us to finally understand its language. If the rings of Saturn hold one secret, the archives of humanity might just hold the key to the next. When every natural law fails to provide an answer, the human mind turns to the most profound possibility of all. Could Saturn's silent flip be the first verified act of an extraterrestrial intelligence? This is not the stuff of science fiction, but a serious, if speculative, line of inquiry now being debated in the highest scientific circles. The theory suggests that what we witnessed was not a natural disaster, but a technological marvel, a planetary-scale engine or a directed energy beam of unimaginable power used to deliberately reverse a world's spin. The motivation could range from a simple test of capability to a deliberate message, a cosmic hello designed to shake humanity from its intellectual slumber. How could we possibly distinguish a natural event from an artificial one? Scientists are now treating the entire Saturnian system as a crime scene, searching for forensic clues of intelligent design. They are looking for a signature of impossible precision, an energy efficiency that defies the messy, wasteful nature of cosmic accidents. Did the reversal occur at a mathematically significant moment, perhaps aligned with a fundamental constant or a prime number sequence? Was the energy applied with a surgical precision that left the rings untouched, a feat no known natural force could achieve without collateral damage? The implications of a yes are staggering. It would mean we are not alone, and that another intelligence possesses a mastery over physics that we can barely comprehend. The ethical questions would be immediate and profound. Do we attempt to reply, risking contact with a civilization that could be benign or hostile? Or do we simply listen, learning from their technological signature as a student might learn from a master's work? Organizations like the Search for Extraterrestrial Intelligence, SETI, have already begun a dedicated campaign. Their radio telescopes are no longer just pointed at distant stars, but are finely tuned to monitor Saturn itself, listening for any repeat signal, any structured pattern in the residual radiation or gravitational waves that might whisper of a guiding hand. The scientific community remains deeply divided, with skepticism being the default and necessary position. Most experts still fervently believe a natural, if unknown, explanation will eventually be found. Yet, a growing number acknowledge that this event has shattered our definition of the possible. To dismiss the idea outright is to ignore the most fundamental rule of science itself, to follow the evidence wherever it leads, no matter how strange the path may seem. The silent spin of Saturn has forced upon us a humbling new reality, where the line between astrophysics and archaeology has blurred. We are no longer just studying a planet, we are potentially deciphering an artifact. Saturn's new climate is a roiling testament to its invisible wound. The planet's mid-latitudes, once stable, are now nurseries for superstorms. These are not the fleeting vortices of the past, but permanent, churning fixtures that rage for months, their cloud tops reaching heights never before recorded. The engine for this chaos is the Coriolis effect, the same force that dictates the spin of hurricanes on Earth, but now operating in reverse. This fundamental shift has rewritten the rules of Saturn's weather. Jet streams that once flowed like disciplined rivers now collide and shear, spawning bizarre, spiral cloud formations that look less like weather patterns and more like galactic whirlpools. The planet's iconic banded structure is slowly, painfully reasserting itself, but the new bands are darker, more turbulent, and edged with a haze of crystallized ammonia whipped up from the deep. Orbiting observatories track these changes with the urgency of doctors monitoring a critical patient. They have mapped drastic temperature redistributions, with the poles warming significantly while equatorial regions experience an unexpected deep freeze, a complete inversion of the old thermal order. To make sense of this, scientists have turned to an unexpected tool: climate models built for Earth. These complex computer simulations, fed with Saturn's new rotational data, are being used to forecast the giant's future. The models suggest two possible paths. The planet could eventually settle into a new, stable equilibrium, its appearance forever altered but its rotation steady in this backward state. Or the atmospheric turmoil could trigger a secondary instability, perhaps leading to a wobble or even another, slower reversal over millennia. This makes continuous monitoring not just a scientific curiosity, but a necessity. We are witnessing a billion-year atmospheric process compressed into a human timescale, a real-time experiment in planetary fluid dynamics. The violent weather on this distant gas giant, born from a broken spin, is teaching us profound lessons about the delicate balance that governs all atmospheres, including our own. Saturn's family of moons now holds critical clues to the planet's internal trauma. Each of these orbiting bodies is locked in a delicate gravitational dance with the giant, and a sudden reversal of their partner's spin would send invisible tremors through the entire system. The most immediate evidence comes from the subtle but measurable changes in their orbits. Precise tracking has revealed that the paths of moons like Mimas and Enceladus have minutely widened, while the massive Titan has experienced a slight, unexpected wobble in its trajectory. These are not random shifts, they are the direct result of a massive transfer of angular momentum. When Saturn's core reversed, it effectively pushed against its moons gravitationally, and their orbits are the recoil from that cosmic shove. This gravitational interplay is most dramatically visible on the moon Enceladus. This small, ice-covered world was already famous for its southern polar geysers, where tidal forces from Saturn's gravity squeeze its interior, heating it enough to spew water vapor into space. Since the reversal, that tidal heating has intensified. Orbital observations show the geysers have become a continuous, raging plume, erupting with a ferocity never before recorded. The surface around the tiger stripe fractures, the source of these geysers, shows fresh, bright ice, indicating recent and violent geologic activity. Enceladus is screaming under the stress of Saturn's new gravitational rhythm, its icy shell flexing and cracking with renewed vigor. This is not just a spectacle, it is a direct barometer of the colossal forces now at play deep within Saturn itself. Could the moons have actually caused the reversal? Some theoretical models explore a fascinating, though incredibly unlikely, chain reaction. Saturn's moons are not independent. They are often in orbital resonance, where their gravitational pulls reinforce each other at regular intervals. For example, Mimas and Tethys are in a 2-to-1 resonance, meaning Mimas orbits twice for every one orbit of Tethys. Under an almost impossibly perfect alignment, the collective gravitational tug of multiple moons in resonance could, in theory, create a feedback loop. This loop could build up enough torque to overcome the planet's rotational stability, essentially using the moon's own gravity as a lever to flip the world. The problem is that our observations of the Saturnian system for decades show no such perfect alignment was occurring. The odds of this happening are astronomically low, yet the event itself was astronomically impossible, forcing scientists to at least consider if this known mechanism could operate in a way we have never witnessed. The implications of this moon-planet relationship now stretch far beyond our solar system. For years, the search for habitable worlds has focused on planets within a star's Goldilocks zone. But Saturn's event highlights that a gas giant's moons can be transformed by the dynamics of their host. The sudden increase in tidal heating on Enceladus demonstrates how a planet's internal behavior can directly dictate the habitability of its satellites. This makes us rethink the thousands of exoplanets we have discovered. A distant gas giant outside the traditional habitable zone might have a frozen moon rendered lifeless and cold. But if that giant experienced a similar internal shift, a reversal or a wobble, the resulting tidal forces could melt that moon's interior, creating a subsurface ocean and potentially birthing life in the darkness. The silent catastrophe at Saturn has given us a new equation for life in the cosmos, one where planetary instability is not always an end, but could be a violent, unlikely beginning. The sheer energy needed to reverse a planet is almost beyond human comprehension. To stop Saturn's 10-hour spin and send it spinning the other way requires overcoming its immense rotational kinetic energy. A simple calculation using the planet's mass and speed reveals a number so vast it dwarfs the total energy output of our Sun for an entire year. This is energy on the scale of a supernova, not a silent event in our celestial backyard. A solar flare, the most violent eruption from our Sun, is a mere spark by comparison. So where could such an unimaginable power source possibly hide? One potential reservoir lies within Saturn itself, in the form of gravitational potential energy. If the planet's deep interior suddenly collapsed or rearranged itself, like a skyscraper's floors shifting and settling, the release of that stored gravitational energy could, in theory, be converted into rotational motion. Another internal source is the colossal energy trapped within Saturn's own magnetic field. A catastrophic magnetic reconnection event, where the field's structure snaps and realigns, could unleash a torrent of power capable of jerking the core in a new direction. Yet even the most generous estimates suggest these internal reserves fall woefully short of the required amount. They are a firecracker trying to topple a mountain. This energy deficit forces us to look for an external source or a more exotic internal trick. Could the planet have somehow tapped into the quantum vacuum, harnessing the seething zero-point energy that exists even in empty space? Or perhaps an intense burst of cosmic rays, a focused beam from a distant cataclysm, delivered the necessary punch. The feasibility of these mechanisms in a stable planetary environment, however, is deeply questionable. They belong to the realm of speculative physics, not the well-mapped territory of planetary science. This leaves us with a profound conservation of energy dilemma. The event seems to have created energy from nothing, a clear violation of one of physics' most sacred principles. To resolve this, theoretical physicists are now exploring radical new models of energy transfer. They are asking if energy could be borrowed from another dimension or from the fabric of spacetime itself, to be paid back almost instantly, leaving no permanent ledger of the transaction. They are modeling scenarios where the reversal was not a transfer of energy, but a redefinition of it within a temporarily warped region of space. The silent flip of Saturn may ultimately teach us less about planets and more about energy itself, forcing a breakthrough that redefines what we consider possible and revealing new, untapped power sources that could one day reshape our own civilization. News of the reversal did not stay in scientific circles for long. A low-level murmur on astronomy forums exploded into a global media firestorm overnight. The impossible story, too incredible to contain, was picked up by every major news network, each competing with increasingly dramatic headlines about the planet that broke the rules. Social media feeds were flooded with side-by-side animations, one showing Saturn's old rotation, the other its new, impossible spin. Hashtags like Saturn Flip and Backwards Planet trended for weeks, while online communities fractured into camps, some convinced it was a government hoax, others certain it was a sign of the apocalypse. Dedicated television specials aired, complete with dramatic music and CGI renderings of the event, trying to visualize the unimaginable. In the midst of this frenzy, the world's scientists found themselves on the front lines of a different kind of communication. They stepped out of their labs and into press conferences, their task not just to share data, but to calm a public whose sense of cosmic order had been deeply shaken. They patiently explain the difference between what they knew for certain and the vast ocean of what they did not, acknowledging the profound mystery while gently debunking the wilder conspiracy theories. Articles written for popular science magazines became essential reading, translating complex theories about dark matter and quantum gravity into language anyone could grasp, transforming public fear into fascinated curiosity. This collective awe spilled over into human creativity. Digital artists created stunning portraits of a turbulent, banded Saturn, its new storms rendered in vivid detail. Poets and authors found inspiration in the event, writing stories of cosmic loneliness and sudden change, using the planet as a metaphor for upheaval in our own lives. Even internet memes got in on the act, with Saturn depicted as a rebellious teenager suddenly deciding to spin the other way just to be different. This cultural moment reflected something deep within us, a timeless fascination with the heavens and a renewed questioning of our small but significant place in the cosmos. The most tangible outcome of this global captivation was a surge in public support for space exploration. Petitions circulated calling for a new, dedicated mission to Saturn, and government space agencies saw a noticeable uptick in their funding discussions. People who had never before looked up began buying telescopes, joining local astronomy clubs, and participating in citizen science projects, hoping to contribute to the solution or simply to witness the next great cosmic wonder for themselves. The silent spin of a distant giant had, against all odds, turned millions of faces back toward the sky, united in wonder. This cosmic mystery has ignited a technological revolution on Earth. To understand a force that can flip a planet, we first had to build new eyes and ears. The sudden reversal of Saturn exposed a critical weakness in our scientific toolkit. Our instruments were simply not designed to monitor the solar system in real time for such bizarre events. The immediate scramble was to repurpose everything we had. The James Webb Space Telescope, originally built to peer at the earliest galaxies, was swiveled to stare at Saturn. Its powerful infrared gaze cut through the upper haze of the planet's atmosphere, revealing hidden layers of churning storms and temperature gradients in stunning detail. This data was like a medical scan of a patient in trauma, showing how heat and energy were redistributing across the globe in the wake of the cataclysm. But processing this deluge of information required a new kind of brain. Data centers around the world began running novel algorithms, machine learning programs trained to spot subtle anomalies in gravitational data and atmospheric flow that human analysts might miss. These algorithms had to work at unprecedented speeds, turning raw data into actionable insights almost instantly. The need for speed and sensitivity has sparked a race to build entirely new classes of observatories. Proposals are now on the table for dedicated Saturn orbiter missions, unlike anything we have launched before. These would not be general-purpose probes, but specialized sentinels equipped with ultra-sensitive gravitometers to map the planet's inner mass distribution by feeling its subtle gravitational tugs. They would carry advanced magnetometers to detect the faintest tremors in Saturn's magnetic field, searching for the echoes of that internal seizure. Perhaps most critically, aerospace engineers are now designing spacecraft for rapid deployment, stored in Earth orbit and ready to launch at a moment's notice toward any future anomaly in the solar system. This push for faster, smarter, and more flexible observation is creating a global network. International space agencies, once competitors, are now linking their ground-based telescopes and orbital assets into a single, coordinated solar system monitoring system. This new web of eyes watches the planets not as static objects, but as dynamic, living worlds capable of sudden change. The technological fallout from this event is already reaching back to Earth. The same advanced algorithms parsing Saturn's chaotic weather are being adapted to improve our own climate and hurricane prediction models. The sensitive spectrometers developed to analyze the planet's atmospheric chemistry are finding uses in monitoring pollution and industrial emissions. Even the work on compact, powerful gravitometers could one day lead to new methods for mapping Earth's own shifting interior, aiding in mineral exploration and geothermal energy development. The silent spin of a distant world is not just a puzzle for astronomers, it has become a powerful engine for innovation, forcing us to see further, think faster, and build smarter, forever changing how we watch the sky. This single event forces us to confront a universe that is not the steady, predictable clockwork we once believed it to be. For centuries, human civilization has built its understanding of reality upon a foundation of cosmic constants, the reliable rhythms of planets and stars that gave us seasons, calendars, and a profound sense of order. Saturn's silent defiance shatters that illusion. It reveals a cosmos capable of sudden, radical change, a place where the rules we consider absolute can be rewritten in a single night. This is not merely a scientific problem, it is a deep philosophical tremor that questions the very nature of causality and stability. If a planet can reverse its spin without a cause we can identify, what does that say about our search for reason in the universe? Are we living in a system of elegant laws, or within a reality that is fundamentally more chaotic and unpredictable than we ever dared to assume? This event echoes the core concerns of existential philosophy, underscoring the profound fragility of human knowledge. We are reminded that our understanding is a tiny island in a vast, unknown ocean, and that the ground beneath our feet, both literal and intellectual, is far less solid than we pretend. It inspires a necessary and humbling cosmic perspective, forcing us to acknowledge forces at work that are entirely beyond our control or even our current comprehension. This humility is now sparking unexpected dialogues in the most fascinating places. Scientists who deal in empirical data and theologians who explore faith are finding common ground in this mystery. For some religious and cultural groups, the reversal is not a puzzle to be solved, but a divine sign, a reminder from a higher power about the limits of human arrogance and the ultimate unpredictability of creation. Across the globe, people are asking if this was a message, a warning, or simply a demonstration of a power so far beyond our own that it appears miraculous. These conversations are not about contradicting science, but about grappling with the meaning of such an event for a species that has always looked to the heavens for both answers and questions. The broader existential questions are now unavoidable. What is humanity's true role in a cosmos where even planetary constants can shift? We have spent centuries trying to master our environment and map our universe, yet this single event shows us that the universe itself is a dynamic and potentially volatile participant. Our future explorations can no longer proceed under the old assumptions. We must now venture forth with a new kind of curiosity, one that accepts the possibility of the impossible and remains open to wonders that challenge the very framework of our reality. The silent spin of that distant ringed world is more than an anomaly. It is an invitation to rethink everything we thought we knew about our place in the stars. The most urgent question now hangs in the silence of space. Will Saturn flip again? Scientific models born from this crisis suggest a terrifying possibility that this was not a one-time fluke but part of a hidden cyclical process. The forces that caused it, whether a buildup of internal stress or the periodic passage of an unseen dark matter clump, might operate on a timer. The cycle could be tens of thousands of years, or it could span hundreds of millions, explaining why we have never witnessed such an event before in recorded history. This transforms Saturn from a static jewel into a ticking clock, its next reversal potentially already counting down deep within its metallic heart. If this is a cycle, then Saturn is not alone. Jupiter, with its own churning metallic hydrogen interior and powerful magnetic dynamo, could be susceptible to a similar internal seizure. Uranus, already tilted on its side from a likely ancient impact, might be poised for its own bizarre rotational shift. The entire solar system of gas giants could be a collection of dormant volcanoes, each capable of erupting in a silent, rotational rebellion. This realization has triggered a new, global imperative, continuous and precise monitoring of every giant planet's spin. By tracking the minute rotational rhythms of Jupiter and Uranus with the same intensity we now watch Saturn, we might detect the early warning signs: a subtle wobble, a slight change in magnetic field strength, or an unexplained atmospheric shudder that signals the buildup to another cataclysm. Finding a pattern here would be one of the greatest discoveries in astronomy, revealing a fundamental, rhythmic pulse to planetary life we never knew existed. For Saturn itself, the long-term future is written in its churning clouds and delicate rings. Will it settle into this new backward spin as its permanent state, or is this just the first violent shudder in a longer series of reversals? Climate models suggest its atmosphere may eventually calm, its jet streams reforming into a new, stable banded pattern aligned with its current rotation. But this new equilibrium could be fragile. The tremendous energies involved might have injected a persistent wobble, a planetary precession that makes its axis slowly dance over millennia. This wobble would have profound consequences, subjecting its rings to new gravitational stresses that could, over millions of years, cause them to ripple, warp, or even collapse inward. The very identity of the ringed planet could be fundamentally altered. This is why sustained observation is not merely academic, it is a necessity for understanding our home in the cosmos. No single nation or telescope can shoulder this burden alone. It requires a united front, a global network of observatories and space agencies sharing data in real time, watching the giants with unwavering eyes. Predicting the next great flip is about more than just avoiding surprise. It is about unlocking the deepest truths of how planets are born, live, and change. It is about preparing humanity for the next cosmic revelation, reminding us that we live in a dynamic, evolving system where even the most constant points of light in our sky hold the potential for silent, world-shattering change. Our journey began with a single, silent night that shattered a fundamental truth of our solar system. From the first impossible data points to the global scramble for answers, we have stood witness to a cosmic event that defies every law we thought governed the heavens. We have navigated the chaos of Saturn's reversed atmosphere and pondered the eerie stillness of its rings, which remained calm while the world they orbit turned itself inside out. We have explored the spectrum of explanations, from the gravitational tug of a dark matter clump to a planetary-scale magnetic seizure, from the warping of space-time itself to the staggering possibility of a message from beyond. Each theory, no matter how mind-bending, confronts the same humbling reality: our current understanding of physics is incomplete. This single event is a powerful reminder that the universe is not a placid, predictable clockwork, but a dynamic and often mysterious arena, capable of wonders that challenge the very core of our knowledge. It is a call to remain curious, to keep looking up, and to support the scientific research that bravely ventures into these unknown frontiers. We want to hear your thoughts on this cosmic enigma. What do you believe reached out and spun a world backwards? Share your ideas in the comments below and join the global conversation. For humanity's quest for knowledge is far from over. It is an endless journey fueled by moments of profound wonder. Mysteries like the silent spin of Saturn are not barriers. They are the very invitations that beckon us to dive deeper, to question further, and to forever explore the vast, unknown depths of the cosmos.